Remember those epic lightsword battles in Star Wars? Those were lasers. They seemed like pure fantasy back then. But lasers aren't just for science fiction anymore. They have become a part of our reality. From scanning groceries to performing delicate surgeries, lasers are now essential tools in our everyday lives, making tasks easier and more efficient. What makes them so special? Why are they so unique? It's their incredible ability to produce a very unique kind of light, unlike any other. This light, unlike the light from the sun or a light bulb, is highly organized and focused, making it extremely powerful. This unique light is what we call coherent light, a special type of light. Think of it like a perfectly synchronized marching band where everyone moves in step, creating harmony. That's what the light waves in a laser do. They move together in perfect unison. They march together with incredible precision, making lasers highly effective. This coherence gives lasers their amazing properties and makes them so incredibly useful in various fields. Let's dive deeper into the fascinating world of lasers and explore their remarkable capabilities. Join us on this journey. We've all seen light, but laser light is different. It possesses a special property called coherence. Imagine a group of runners all starting a race at the exact same time. That's temporal coherence. All the light waves in a laser start their journey together in sync. Now imagine those runners all running in the exact same direction, perfectly aligned. That's spatial coherence. All the light waves in a laser travel together in the same direction. This togetherness makes laser light incredibly intense and focused, unlike regular light, which spreads out in all directions. This special light is what gives lasers their incredible power and versatility. Lasers are true multitaskers capable of performing a wide range of tasks. In medicine, lasers are used for everything from correcting vision to removing tumors with precision. Surgeons rely on the precision of lasers for delicate procedures, ensuring better outcomes. In manufacturing, powerful lasers cut and weld materials with incredible accuracy and efficiency. Think of those perfectly cut pieces in your smartphone. That's the magic of lasers. But that's not all. From scanning groceries at the checkout to playing music on CD players, lasers are everywhere in our daily lives. They even power the internet by sending data through fiber optic cables at lightning speed, connecting the world. And let's not forget about entertainment. Laser light shows are a feast for the eyes, dazzling audiences everywhere. Lasers truly are versatile tools that touch almost every aspect of our modern lives, making them indispensable. Section 4. Optical fibers, guiding light at the speed of information. Imagine a long, thin strand of glass so pure that light can travel through it for miles with minimal loss. That's an optical fiber. These amazing threads are the backbone of our modern communication networks, enabling the rapid exchange of information across the globe. But how do they work? Let's dive into the fascinating science behind it. Think of a hose with water flowing through it. The concept is quite similar. The water is guided by the walls of the hose, ensuring it flows smoothly. Optical fibers do the same thing with light, using a principle called total internal reflection. Light bounces back and forth inside the fiber, guided along its length with remarkable efficiency. This allows for incredibly fast data transmission over long distances, making our digital world possible. Optical fibers come in different types, each optimized for specific applications like high-speed internet, medical imaging, and even underwater communication cables that connect continents, bridging the gap between distant lands. Section 5. Lasers on a mission measuring distance and speed. Lasers are incredibly precise measuring tools. Remember those runners we talked about earlier? Lasers use the time it takes for light to travel to a target and back to measure distance with incredible accuracy. This technique, called LiDAR, is revolutionizing fields like surveying, archaeology, and even self-driving cars. But lasers can also measure speed. By bouncing light off a moving object and analyzing the reflected light, we can determine its velocity. This is how police officers use laser guns to catch speeding drivers. From mapping the Earth's surface to tracking the movements of distant galaxies, lasers are essential tools for understanding our world. Section 6. A world transformed, the impact of lasers. Lasers have revolutionized our world in countless ways. In medicine, they've enabled minimally invasive surgeries, faster healing times, and even the correction of vision. In industry, lasers have increased manufacturing precision, speed, and efficiency. Our communication systems rely heavily on lasers for fast and reliable data transfer. From scientific discoveries to entertainment, lasers have become indispensable tools in our modern world. As laser technology continues to advance, we can expect even more groundbreaking applications to emerge, further shaping the future and improving our lives in ways we can only imagine. Section 7. Learn more. Keep exploring the world of lasers. This is just a glimpse into the fascinating world of lasers. From their unique properties to their wide range of applications, lasers continue to amaze and inspire. If you're eager to dive deeper into this captivating field, there are countless resources available online and in libraries. Explore, discover, and keep asking questions.
Hey there, science fans! Welcome to a journey where we explore one of the most incredible forces in our universe, light. Whether you're a curious student, a tech enthusiast, or just someone who loves to learn, you're in for a treat. Today we're going to uncover how light isn't just something that helps us see, but is actually the ultimate messenger, carrying information across the globe at mind-blowing speeds. Let's talk about light. It's everywhere, streaming through your window in the morning, illuminating city streets at night, and even pulsing invisibly through cables beneath our feet. Light is how we see the world, but it's also the backbone of modern communication. Every second, billions of messages, videos, and calls are zipping around the planet, all thanks to light. Think about it. Every time you make a phone call, stream your favorite show, or video chat with a friend across the world, you're relying on light. It's the invisible hero behind the scenes, making sure your voice, your images, and your data get where they need to go, almost instantly. But how does this actually work? How can light travel such long distances without getting lost or scattered? The answer lies in a remarkable invention, optical fibers. These are ultra-thin strands of glass or plastic designed to trap light inside and guide it along winding paths, even under oceans, connecting continents and people everywhere. Optical fibers are like tiny, flexible highways for light. They keep the light signals strong and focused, allowing us to send massive amounts of information over thousands of kilometers with barely any loss. Without them, our internet, phone networks, and even cable TV would be much slower and less reliable. And when we need light to be even more precise and powerful, we use lasers. Lasers produce beams of light that are incredibly focused and intense, perfect for sending information, performing delicate surgeries, or even cutting through metal with astonishing accuracy. From high-tech factories where lasers slice through steel, to hospitals where they help doctors perform life-saving operations, lasers are transforming industries and improving lives every day. Their precision and power make them essential tools in our modern world. So buckle up, because we're about to dive deep into the fascinating world of light, optical fibers, and lasers. Get ready to discover how these technologies shape our lives, connect our world, and open up endless possibilities for the future. Imagine a group of kids playing outside, taking turns jumping rope together. Each child waits for the right moment, watching the rhythm of the rope as it swings around. When everyone pays attention and jumps at just the right time, something magical happens. If all the kids are jumping in perfect unison, the rope moves smoothly, creating a beautiful, even wave. This is a lot like what happens with coherent light. In coherent light, all the light waves are lined up, moving together in harmony, just like those synchronized jumpers. The result is a steady, predictable pattern that can travel long distances without losing its shape. But what if the kids start jumping at random times, not paying attention to each other? The rope gets tangled, the rhythm is lost, and the wave becomes chaotic. This is what we call incoherent light. The waves are all mixed up, moving in different directions and at different times, so the pattern falls apart quickly. Most of the light we see every day, like sunlight streaming through your window or the glow from a light bulb, is incoherent. The waves are jumbled, which is why the light spreads out and doesn't stay focused. Scientists talk about two main ways that light can be in sync, or coherent. These are called temporal coherence and spatial coherence. Understanding these helps us see why some light behaves so differently from others. Temporal coherence is all about timing. Imagine our group of kids. each one jumping at exactly the right moment over and over again. The rope's motion stays smooth because everyone's timing matches up, not just for one jump, but for many jumps in a row. In light, temporal coherence means the waves stay in sync over time, creating a consistent, steady beam. Spatial coherence, on the other hand, is about being in sync across space. Think of a marching band where every member steps in time side by side, forming straight lines as they move forward. For light, spatial coherence means the waves are lined up not just in time, but also across the width of the beam, so the light stays focused and doesn't scatter. Lasers are truly special because they produce light that is both temporally and spatially coherent. All the waves are perfectly lined up, both in timing and in direction. This is why a laser beam can travel far without spreading out, and why it can be so precisely controlled. Thanks to this unique property, laser light is incredibly powerful and useful. It can cut through metal in factories, perform delicate surgeries in hospitals, and even help us communicate across the world with fiber optics. Coherence is the secret behind the laser's amazing abilities. Optical fibers are like tiny tubes made of glass or plastic. They're thinner than a hair, but can transmit light for incredibly long distances. How do they do it? It's all about a cool phenomenon called total internal reflection. Imagine a beam of light traveling inside the fiber. When it hits the edge at a shallow angle, it bounces back in. That's total internal reflection. This keeps happening, bouncing the light down the fiber like a race car on a track. This is how light travels through optical fibers, carrying information with incredible speed and efficiency. Not all optical fibers are created equal. In fact, the world of fiber optics is surprisingly diverse, with each type of fiber designed to meet specific needs and challenges. Just as you wouldn't use a paintbrush to hammer a nail, engineers carefully select the right fiber for the job at hand. The differences between fibers might seem subtle at first glance, but they have a huge impact on how information travels across the globe. There are different types designed for specific jobs. Some are built for speed, others for distance, and some for flexibility in tight spaces. The choice of fiber can determine how fast your internet is, how clear your video calls are, or how efficiently data moves between continents. Single-mode fibers are like the express lane of the information superhighway. They're engineered to carry light signals straight down a very thin core, with almost no detours or distractions along the way. They're super thin, about the width of a human hair, and only allow one light path or mode to travel through them. This design minimizes signal loss and interference, making single-mode fibers perfect for long-distance high-speed data transmission. That's why they're the backbone of undersea internet cables, connecting continents and powering global communication. You'll also find them in massive data centers, where speed and reliability are critical. Multimode fibers, on the other hand, are more like a multi-lane highway. Their cores are much thicker, allowing several light paths or modes to travel side by side. Because they're thicker and allow multiple light paths, multimode fibers can carry more data at once over short distances. However, the different paths can cause the signals to spread out and blur over long distances, so they're best for shorter connections. This makes them great for connecting computers and devices within an office building, a campus, or a data center, where the distances are relatively short, but high bandwidth is needed. They're also easier to install and often more cost-effective for these applications. Within multimode fibers, there are two main types, step index and graded index. Each has its own way of guiding light and managing data flow. Step index fibers have a sudden sharp change in refractive index between the core and the cladding. This causes light to bounce off the boundary in a zigzag pattern, which can lead to more signal distortion over distance. Graded index fibers, however, have a core where the refractive index gradually changes from the center outward. This smooth transition bends the light gently, keeping the signals more focused and reducing distortion. As a result, graded index fibers can transmit data more clearly and efficiently over longer distances than step index fibers. So, whether it's for crossing oceans or connecting office floors, there's a fiber designed for every need. So why are optical fibers such a big deal? Well, for starters, they can transmit much more data than traditional copper wires. They're also immune to electromagnetic interference, which means they're not affected by things like power lines or lightning. This makes them incredibly reliable. Plus, they're lighter and thinner than copper wires, making them easier and cheaper to install. And because they use light instead of electricity, they're much more energy efficient. That's why optical fibers are quickly becoming the go-to choice for communication networks around the world. Now let's talk lasers. Unlike regular light, which spreads out, laser light is focused into a narrow beam. This makes it incredibly powerful and precise. But what makes lasers so special? It all comes down to the way they generate light. Lasers use a process called stimulated emission to amplify light waves. This creates a beam of light that's both coherent and monochromatic, meaning all the light waves have the same wavelength and are in sync. This makes laser light incredibly intense and focused, perfect for a wide range of applications, from cutting and welding to medical procedures and even navigation. Ever wonder how airplanes and submarines find their way without GPS? They often rely on a clever device called a laser gyroscope. Unlike traditional gyroscopes that use spinning wheels, laser gyroscopes use light to detect rotation. Here's how it works. A laser beam is split into two beams that travel in opposite directions around a closed loop. When the gyroscope rotates, it creates a tiny difference in the path length of the two beams. This difference, called the Sagnac effect, is detected and used to calculate the rate and direction of rotation. Laser gyroscopes are incredibly precise and reliable, making them ideal for navigation systems. They're used in airplanes, ships, submarines, and even spacecraft to provide accurate heading and attitude information. But their uses don't stop there. Laser gyroscopes are also found in robotics, oil drilling equipment, and even your smartphone. They're essential for applications that require precise motion sensing and control, making them a vital part of our increasingly technological world. Lasers have revolutionized many industries, and their applications continue to expand. In defense, lasers are used for target designation, missile defense systems, and even experimental weapons. In manufacturing, lasers cut and weld materials with incredible precision, creating everything from cars to smartphones. Medicine has also benefited greatly from lasers. Surgeons use lasers for delicate procedures like eye surgery and tumor removal. Lasers are also used in cosmetic procedures, barcode scanners, and even entertainment like laser light shows. The possibilities seem endless. So there you have it. From optical fibers enabling global communication to lasers transforming industries, light is truly shaping our world. As we continue to unlock the secrets of light, who knows what amazing discoveries await us in the future? Keep those questions coming and never stop exploring the wonders of science.
Hello, young explorers. Are you ready to embark on a journey into the world of science and discovery? Today, we're going to learn about something truly amazing: lasers. You might have seen lasers in movies, at science fairs, or even in your own classroom. But have you ever wondered what makes a laser so special, or how it works? Let's find out together. Today we're diving into the fascinating world of lasers. Lasers are not just ordinary lights. They are a special kind of light that scientists and engineers use for all sorts of cool things. From helping doctors perform delicate surgeries to making your favorite music CDs and even scanning barcodes at the grocery store, lasers are everywhere. Lasers are like beams of light with superpowers. Unlike a flashlight or a lamp, which spreads light all around, a laser creates a beam that is incredibly straight and focused. This means it can travel long distances without spreading out or losing its strength. That's why you can see a laser pointer's dot on a wall far away, even in a big room. They're different from the light from a light bulb or the sun. The light from a bulb or the sun is made up of many colors and spreads out in all directions, filling up the whole room or even the whole sky. But a laser's light is usually just one color, and it travels in a perfectly straight line. Those lights spread out in all directions. That's why when you turn on a lamp, the whole room lights up, and when the sun shines, it lights up the whole world. But lasers are different. They don't scatter their light. Instead, they keep it all together in a tight, powerful beam, but a laser's light stays together in a narrow beam. This is called being coherent, which means all the light waves are lined up and moving together. That's what gives lasers their amazing power and precision. It's like all the runners in a race moving in perfect sync, instead of running in different directions. This makes it very powerful and able to do amazing things. Lasers can cut through metal, help doctors fix your eyes, and even send messages through space. They're used in science, medicine, art, and even in your favorite video games and toys. Isn't that incredible? Lasers make heat because of the way they focus energy. When a laser beam shines on something, it can get very hot, very quickly. That's why lasers can cut, burn, or melt things, even though they look like just a simple beam of light. Imagine lots of tiny balls of light energy, all moving together in the laser beam. These tiny balls are called photons, and in a laser, they all travel in the same direction at the same time, like a team working together. This teamwork is what makes the laser so strong and focused. When these energy balls hit something, they get absorbed. The energy from the laser beam goes into the material, and something amazing happens. The atoms inside the material start to move faster and faster. This makes the object's atoms vibrate really fast, and that's what we feel as heat. So the next time you see a laser, remember, it's not just a cool light. It's a powerful tool that uses science to do incredible things. Get ready, because there's so much more to discover about lasers. Lasers are like tiny, super precise tools that can change the surface of materials. But what does that really mean? Imagine a beam of light so focused and powerful that it can actually alter the very top layer of metal, glass, or even plastic, all without touching it physically. This is the magic of laser surface modification, a technology that's revolutionizing how we make things stronger, more durable, and even more beautiful. This process, called laser surface modification, uses the energy from a laser to change the properties of a material's surface. By carefully controlling the laser's intensity, speed, and focus, we can achieve a wide range of effects, from hardening metal to making it resistant to corrosion, or even giving it a completely new color or texture. It's a bit like painting with light, but instead of adding something on top, we're actually transforming the material itself at a microscopic level. With laser surface modification, we can make things much harder, so they last longer and stand up to more wear and tear. For example, tools that are treated with lasers can keep their sharp edges for much longer, and machine parts can resist scratching and denting, even in tough environments. Lasers can also be used to create vibrant colors on metal surfaces, without using any paint or chemicals, just by changing the way light reflects off the surface. This technology isn't just for heavy industry. It's used in everything from jewelry, where lasers create intricate patterns and colors, to medical devices that need to be both strong and sterile. Even the decorative finishes on your favorite gadgets might be the result of laser surface modification. Imagine making a tool that never gets dull, or a phone screen that never scratches. That's the power of lasers. By precisely controlling where and how the laser is applied, manufacturers can create products that are not only more reliable, but also more attractive and unique. This means longer-lasting tools, more durable electronics, and even custom designs that were impossible before. The secret behind this technology is the laser's ability to heat materials in a very controlled way. Unlike traditional methods that might heat an entire object, lasers can focus their energy on a tiny area, heating it up in just the right spot and for just the right amount of time. This precision means less waste, less damage, and better results. We can heat just a tiny spot without affecting the rest of the object. This is especially important when working with delicate or complex parts, where you don't want to risk warping or damaging the whole piece. The laser's pinpoint accuracy allows for modifications that are impossible with traditional tools. This lets us change the material's properties exactly where we want to. Whether it's hardening the edge of a blade, adding a decorative pattern, or making a surface more resistant to rust, lasers give us total control over the process. The result is a product that's perfectly tailored for its job. In fact, laser surface modification is so precise that it's often used in industries where even the tiniest flaw can cause big problems, like aerospace, automotive, and electronics. Engineers can program the laser to follow complex patterns, ensuring every part is exactly as it should be. It's like having a microscopic blowtorch with incredible precision. With laser surface modification, we're not just improving materials, we're opening up new possibilities for design, durability, and performance, all thanks to the power of light. Lasers are powerful tools that can do much more than just cut or engrave materials. In the world of modern manufacturing, lasers are used in a variety of ways to change and improve the surfaces of metals and other materials. These advanced techniques allow us to make materials stronger, more durable, and better suited for specific jobs. Today, we'll explore 3 fascinating ways lasers can modify surfaces: cladding, alloying, and hardening. Each of these methods uses the unique properties of laser light to transform ordinary materials into high-performance components that can withstand extreme conditions. The first technique is called cladding. Imagine you have a valuable tool or machine part that needs extra protection from wear, corrosion, or heat. Instead of replacing the whole part, we can use a laser to add a protective layer right on top of the original surface. This process is a bit like putting on a suit of armor, but for metal parts. The laser precisely melts a special material, often a metal powder or wire, onto the surface, creating a new layer that is tightly bonded to the original. This new layer can be made from materials that are tougher, more resistant to chemicals, or better at handling high temperatures than the base material underneath. Cladding is used in industries like aerospace, automotive, and energy, where parts are exposed to harsh environments and need to last a long time. During the cladding process, the laser's intense heat melts the added material just enough so that it fuses with the surface below. This creates a strong, seamless bond between the 2 layers. The result is a component that not only looks new, but also performs better and lasts longer. Because the laser can be controlled so precisely, we can apply the protective layer exactly where it's needed, without affecting the rest of the part. This makes laser cladding an efficient and cost-effective way to repair or upgrade expensive equipment. After cladding, you can often see the difference between the original surface and the new protective layer. Technicians carefully inspect the finished part to make sure the bond is strong and the coating is even. The new layer acts as a shield, protecting the underlying material from damage. This is especially important for parts that experience a lot of friction or are exposed to corrosive chemicals. By using lasers for cladding, we can extend the life of critical components and reduce the need for costly replacements. The next technique is called laser alloying. In this process, we use the laser to melt a mixture of different metals together right on the surface of a part. Think of it like mixing different colors of paint to create a brand new shade, but instead of paint, we're combining metals to make a new alloy. The laser's heat causes the metals to blend at the surface, forming a new material with unique properties. This can make the surface harder, more resistant to wear, or even give it special abilities like resisting rust or conducting electricity better. After laser alloying, the treated surface often looks and behaves differently from the original. Engineers test the new material to see how its properties have changed. For example, a metal that was once soft and easily scratched might become much harder and more durable after alloying. This process allows manufacturers to customize the surface of a part for specific applications without changing the entire component. It's a smart way to get the best of both worlds, the strength of the new alloy on the outside and the toughness or flexibility of the original material on the inside. The final technique is laser surface hardening. Here, the laser is used to heat the surface of a metal very quickly and to a very high temperature. This rapid heating changes the structure of the metal at the surface, making it much harder and more resistant to wear. Unlike traditional hardening methods, which can take a long time and affect the entire part, laser hardening is fast and precise. Only the surface is changed, so the inside of the part stays tough and flexible. This is perfect for gears, shafts, and other parts that need a hard outer shell, but a strong, resilient core. Thanks to these laser-based techniques, we can create materials and components that are stronger, longer-lasting, and better suited for the challenges of modern industry. Lasers are also fantastic for joining materials together, especially metals. Laser welding uses a high-intensity laser beam to melt the edges of 2 pieces of metal. When they cool down, they fuse together, creating a super strong bond. It's like the metal pieces become one. Laser soldering is similar, but we use a lower power laser and a filler metal that melts at a lower temperature. This method is great for joining delicate parts or materials with different melting points. Laser welding and soldering are much more precise than traditional methods, and they create very clean, strong joints. Have you ever seen a laser cutter in action? It's amazing how quickly and precisely they can cut through materials. Lasers can cut through almost anything: metal, wood, plastic, fabric, you name it. They work by focusing a lot of energy onto a tiny spot, vaporizing the material and creating a clean cut. Lasers are also used to drill incredibly small holes. This is especially useful in making electronics or medical devices. Sometimes a special gas is used during laser cutting or drilling. This gas can help blow away the melted material, making the process even cleaner and more efficient. Now, let's talk about how lasers are used in medicine. Lasers have revolutionized many medical procedures, making them safer and more precise. One of the most well-known uses of lasers is in eye surgery. Lasers can correct vision problems like nearsightedness and farsightedness. They can also treat eye diseases and even weld detached retinas back together. Lasers are also used to treat cancer, remove tattoos, and even clear blocked arteries. It's incredible how versatile lasers are in medicine. Imagine wearing glasses or contact lenses every day. Now imagine waking up one morning and seeing clearly without them. That's what laser eye surgery can do. During the procedure, a special type of laser reshapes the cornea, which is the clear front part of your eye. This reshaping helps light focus correctly on the back of your eye, improving your vision. Laser eye surgery is a quick and generally painless procedure that has helped millions of people see the world more clearly. From cutting-edge manufacturing to life-saving medical treatments, lasers have become essential tools in countless fields. They allow us to create things with incredible precision, modify materials in amazing ways, and even heal our bodies. Lasers are powerful tools that are shaping our world one beam at a time, and the possibilities are truly limitless. So, next time you see a laser pointer or a barcode scanner, remember the amazing science behind these beams of light and the incredible things they can do.
As we conclude our exploration of general properties of plasma, we reflect on the journey we've undertaken through the fundamental principles that govern one of the universe's most abundant states of matter. This series has aimed to provide clarity and insight into plasma behavior, wave interactions, and the theoretical underpinnings essential for advancing in the field of plasma physics. We extend our deepest gratitude to Professor Dr. Tarek Farouk Nagla, a distinguished expert at the Nuclear Power Plants Authority in Cairo, Egypt, for his invaluable scientific support throughout this series and beyond. His guidance has been instrumental in enriching our content and ensuring its scientific accuracy. To our dedicated viewers, thank you for joining us on this scientific journey. Your engagement and curiosity drive our mission to disseminate knowledge and foster a community passionate about science. We invite you to continue exploring the wonders of science with us. Subscribe to the For Science Salah Lotfy channel and stay tuned for more enlightening series and discussions. Your support and participation are the catalysts that propel us forward.